Hi, so we're going to get into 4.4.1, which is the solving systems of linear equations by elimination. Now, we've already talked about solving by graphing, right? Back here, we did solving by graphing and we did solving by substitution. Elimination is another way to actually solve. Now, some people like elimination better than the other ways, but I will tell you the hang up for elimination is it only works on problems where you can actually eliminate something. Now, there's some systems that we'll get into, and not for this year, but in a couple of years, you'll get into that elimination doesn't work because you can't eliminate anything from the 2 or 3 or 4 equations that you were given. So that being said, let's go ahead and get started. So the very first thing is it says fill in the blanks, and then it says elimination method is a way to solve a system of equations. Okay, sorry, it's just catching up here. Very good. And so it may be helpful if the other methods, graphing and substitution, are difficult to use with these equations. So, Okay, so the thing that you should know about graphing and substitution is it works on every single system. Okay, substitution and graphing work on every single system, but graphing might be a little bit difficult, especially if the two graphs intersect in a place that is not easy to determine what that solution is. So just kind of keep that in mind. Okay. So adding the equations in a system of equations can sometimes be helpful in solving a systems of equations, and explain why. Well, hold off on this, and then we'll come back to this question, just because right now you haven't done enough to figure out like why it's even helpful. So we'll answer this one towards the end. So number 3, it says identify the systems for which adding the equations eliminates a variable. For those equations, identify the variable you would have to be eliminating. So in this one here, they want you to identify the systems for which adding the equations eliminates a variable. So if I added these two, would a variable be eliminated? And you're like, yeah, look. So when they say adding the equation, it feels weird because you've actually never added equations before. You've added numbers, you added X's, you've added Y's, even in, second grade and third grade, and maybe even in kindergarten, you added blocks or oranges or apples or whatever the case might be, you added. So now this is no different. We're just adding equations together, and it's a pretty neat, nifty way for you to understand how to do this. So if I added these two equations, 2y plus negative 2y is 0. So do you see how those eliminated? So when we say the word eliminate, we mean get rid of. So if we are eliminating, I don't know, sugar from our diet, right? We're getting rid of all sugars, and maybe it's like table sugar. We're getting rid of extra sugar in our diet. Okay, so if I have coffee, I'm not going to add sugar to it, or I'm not going to add anything that has sugar in it. So for example, creamer or anything like that. So if I added these two equations together, would anything eliminate? So I'm going to put a little plus sign here. And you're like 2y plus 2y, no, that's 4y. And 4x plus x, no, that's 5x. So no, this one's going to be a no. Nothing eliminates, right? And for this last one, 2y plus y, that's 3y. And negative 4x plus 4x, oh, that eliminates, right? Because that's a 0, right? So here, and this is a yes. So the thing that you should be thinking of is, okay, well, how do you know what eliminates and what is not going to eliminate? So let me just sync this because these are having a hard time. So in this first case, the y's eliminated. And in that third case, the x's eliminated. Right? Okay. So what do you notice about the y's here? Is that the same thing that you notice about the x's here? And you're like, oh yeah, they're opposites. So yeah, that's exactly what we're doing. So going back up here, it says adding equations in a system can be helpful in solving a system. Why? Because sometimes by just adding the two equations, we're already left with a simpler problem, right? Okay, so show how to solve this using the thing, and then we're just going to follow their steps. So the very first thing it says add down to eliminate a variable. So I'm going to go like this. Oops, that's really big. So sorry, this is a plus sign. Okay, and it says now we're just going to add these two together. So what's 2x plus 4x? And you're like, oh, that's 6x. And what's negative 3y plus 3y? And you're like, oh, that's 0. So do you want me to write 0, Ms. Johnson? No, I do not want you to write 0. And then what's 1 plus 47? Oh, that's 48. So I'll ask you, what would you rather deal with? 6x equals to 48 or 2x minus 3y equals 1 and 4x plus 3y equals 47? And you're like, this one. Very good. So now I want you to solve for x, and you'd say, oh, I know how to do that. That's just x is equal to 8. And I'm like, yep, that's correct. Now, if this was the problem, then this is done. But remember, I told you guys, we are in, because they gave us an x and a y, then we have to solve our system for x and y. So what do you want me to do, Ms. Johnson? The same thing that we did before. So once we find a variable, then we go back to our originals and we plug in to find the other variable. And you plug into whichever one you want. I tend to avoid negatives because I make mistakes with negatives. So I'm going to plug into my second equation, 4x plus 3y equals to 47. And instead of that 8, that x right there, I'm going to put my 8. Okay. And then I just simplify, right? So that's what 32 plus 3y equals to 47. And then that means 3y equals to 15, which means y equals to 5. So here's my x and here's my y. Very good. So I'm going to write my answer as a point, 8, 5. 8 is my x, y is my 5, and then I would check my answer, remembering Ms. Johnson likes checking her answer because she likes to be right. Okay, so because I already plugged it into this equation, I'm only going to plug it into the second one. I would encourage you on a test to plug it into both. Okay, I would encourage you to do both. So I'm going to plop my little 8 and my little 5 in there into the x spot and to the y spot. This is 16 minus 15. Is that equal to 1? And this is a good sign, Ms. Johnson. She likes being right. Right? Very good. So very, very good. All right. So now what do I do, Ms. Johnson? What do I do now? Okay. So it says show how to solve a system of linear equations using elimination. So we just did that. So now we have a little bit of a different one here. So the very first thing that I noticed is I don't have opposites. 3x and x, not opposite. 2y and 2y are not opposites, but they're really close. So this one says subtract to eliminate a variable. I tend not to do that. I tend to change the signs of everybody on the bottom, which is exactly what subtraction is. Subtraction, just as a reminder, 4 minus 2 really means 4 plus negative 2. And you're like, Ms. Johnson, it means the same thing. I know, but for here, if you put a big old subtraction sign here, sometimes Ms. Johnson gets so excited about doing the math that by the time she reaches over here, she forgot and now she's just adding. So here, what I do is I change everybody's sign. So this is going to be minus, and then I change everybody's sign to their opposite. So I go negative x, I go minus 2y equals negative 20. Okay, so now I'm going to combine those. Another name for elimination is called combinations, right? Just so that you know some of the names that this is referred to. I think they refer to more as eliminations, and combinations is kind of like an old name for it. So 40 minus 20 is 20. 2y minus 2y is 0y. I'm not going to write it. 3x minus x is 2x's. So that implies that x equals 10, right? By dividing by 2, right? To both 2x and 20, I get x is equal to 10. And then now you'd say, okay, I'm done, Miss Johnson. No, you're not, because did they give you x and y? Yes. So then you have to find x and y. So again, how do I do that? I go back to my original equations and plug it in. Now, I think I like this equation better, that x plus 2y equals to 20, because that has smaller numbers. So I'm going to use that. And I get x plus 2y equals to 20, right? So I'm going to plop that 10 right in there. So then that implies that 2y equals to 10 and y equals to 5. And so here I'm just subtracting 10 on both sides, which you all know how to do, and then dividing by 2, which you also know how to do. So there's my answer, y equals to 5. So I will write my answer as a 0.10 comma 5. Always x comma y, never y comma x, never, right? So x comma y is 10, 5, and then they'd want you to answer, check your answer. I'm going to leave that to you so you can check your answer and make sure that we're right. You need to check your answers, especially, this is like one of those tests I keep saying, right? One of those tests where you can get everything right because you've checked your answer. All right, let's continue. So the next problem that we're going to do is we are going to take care of, this problem here, and it's a word problem. So it says a club sells hot dogs for $2 each, $2 each, and bottled water for $1 each at a school event. They sell a combined total of 80 hot dogs and bottles of water and earned $110. How many hot dogs and how many water bottles did the club sell? So the problem, they already gave you the equation. That was very nice of them, right? Now all you're going to do is solve the equation, right? So the very first thing, so they give you all these steps, which sometimes I like the steps that Apex gives. Sometimes it confuses us. So it says first eliminate the variable by what the equations. Are you going to add these equations? Or are you going to subtract them? What do you think we should do? Should we add these equations or should we subtract them? Okay, so hopefully you said we have to subtract them, Ms. Johnson, because nothing eliminates if we add them. So we're going to circle the word subtract. Okay, so then they want us to do that. So I'm going to subtract these two equations. And remember, when I subtract, I change the sign of everybody. Oops, I did that wrong. So I'm going to change the sign of everybody. So that's negative x, negative y, and negative 80. Oh, it's not catching up to me. Hold on. Okay. Now I'm going to add these equations together or combine them. 110 and negative 80 combine to be 30. Y minus y is 0. 2x minus x is x. So x equals to 30. Right? The next thing, it says substitute the variable into x into the either equation. And I'm probably going to use into the second equation just because I like it better. Oh, actually, sorry, it says either. I didn't realize that was my option, either, in order to solve for y, right? So I'm going to plug it into the bottom equation because I like, it's a lot smaller for me. So I'm going to go x plus y equals to 80. And I'm going to plop this 30 right in the x spot. Okay. So then I'm going to solve, and that y becomes 50. If I subtract 30 from both sides, I get y equals 50. Very good. Okay. So now I'm going to write my point as I'm going to write my answer as in the context. So x, what was x? X represents the hot dog. So 30 hot dogs. 30 hot dogs. And then we got 50 water bottles. Okay. So then it says identify the number of solutions from the description. Two equations are the same. Wait, two equations are the same on one side, but have different constants on the other. So that looks like this. If it looks like, I don't know, 2x plus 4y equals 10, 2x plus 4y equals 30. Okay, two equations that are the same on one side, these are the same, but have different constants on the other. What does that mean? So this is the case of no solution. And the reason why is if I subtracted both of these equations, right? So again, if I subtract, I'm really adding the opposites. I'm going to go through and make everybody as opposite. So notice this says 0 equals negative 20. Can you think of a time where 0 should equal negative 20? Can you think of a time? And you're like, nope. And the answer is you can't. And that's why the answer is no solution. Okay. So this one says one of the equations of the system can be rewritten so it's identical to the other equation. So for example, I'm just going to make up x minus 2y equals 10. And then I'm going to multiply this equation by 2. So I get 2x minus 4y equals 220. So notice they're exactly the same equation. Okay. So this is called infinitely many solutions. Very good. All right. So hopefully this makes sense to you and how to eliminate and how to use elimination. Elimination, this is just the very beginning of you learning it because they set it up for you so you could either add or subtract to get rid of one of your variables. There's going to be a point where I show you a system of equations and you're going to have to do a little bit more work for that. Okay. I hope you have a great day. Thank you so much. Bye.